Howdy, it's Miss Kosh. This video is a follow-up to the cartoon. Okay, so if you didn't watch that cartoon that I posted, I need you to go do that. So I'm assuming that you've seen it, and I'm assuming that you understand what's happening. But if you were in my classroom, I would have played the cartoon for everybody, and I'd have made you watch it, and then I would have talked about a few things. And so this video is to talk about the few things. So I love that video. I mean, that cartoon. It's a little cheesy at times, but I think it's brilliant, and it does a good job of showing what's happening. Okay, so one thing I do want to talk about is this one here, where use sigma notation. So you'll notice that this is a geometric series where the first term, a sub 1, is equal to 9/10, and then the common ratio, each time we get to the next term, we're multiplying it by 1/10. And so the sigma notation, it's the sum as, what do we want to say, as n goes from 1 to infinity of 9/10 times 1/10 to the n minus 1. And I always want to go back and double check and make sure that I did that correctly, and sure when I plug in 1, I get the first term and life is good. And what does this prove? Well, this shows us this would be like 0.9. This is 0.09. This is 0.009. This one is that. Well, and it keeps going. What this is 0.9 repeating. Okay, and so what happens here when we have 0.9 repeating, this drives people crazy, but 0.9 repeating is actually equal to 1. So if you remember, actually, I'm not sure if you remember or not, but the infinite series that we're going to consider, the only one that will actually converge to a particular value is an infinite geometric series when our R value is less than 1. Okay, or the absolute value of R is less than 1, because it could be negative 1/2, and that'd be okay too. But it can't be negative. It can't be negative 2, because that's going to oscillate and then grow. But okay, so that formula is the sum is equal to a sub 1 over 1 minus R. And we can see that, oh, okay, I should watch the video before I talked about this. Do you remember how they were walking to the wall, or the square one? So he had that square, and then he took half of it, and then he took half of that, and then took half of that, and took half of that. So like if you have this piece, and then you have then you take half of it, and then you take half of it, and then you take half of it. That's 1/2 plus 1/4 plus 1/8 plus, well, as that keeps going, if you can do that to infinity, you end up equaling the whole square. So our a sub 1 in this case is 1/2, our R value is 1/2, and so S is equal to a sub 1 over 1 minus R. That's equal to 1/2 divided by 1/2, which, as you know, is equal to 1. Okay, so coming back to this previous problem, this is our formula when the absolute value of R is less than 1. So coming back with this particular problem, if we look at this, our a sub 1 is 9/10, our R value is 1/10, and so I can say, well, I need more space. I can say that the sum is equal to a sub 1 over 1 minus R. The sum is equal to a sub 1 was 9/10. The R value is 1/10. Oh, and look, we have 9/10 divided by 9/10, and this is equal to 1. And every year this blows somebody's mind, and they can't seem to accept the fact that 0.9 repeating is actually equal to 1. Here's another way that I can prove this to you. If you know, what is 1/3? Well, 1/3 is 0.3 repeating. Okay, so if I come along and I say, okay, well, what happens when I multiply both sides by 3? Well, 1/3 times 3 is 1. 0.3 repeating times 3 is 0.9 repeating. And there's another proof to show you that 0.9 repeating is actually equal to 1. There might be a third proof, but I'm not thinking of it off the top of my head, so let me know if you still struggle with that reality. But I think that's pretty cool. Okay, the rest of this, I think what example does the video give to help you understand this situation? Both the square and actually the guy walking to the wall. The rest of my answer key is already posted for you, so you can look through that. But it says, okay, give an example of a decreasing series that diverges. Well, they used the harmonic series, which is 1/2 plus 1/3 plus 1/4 plus 1/5. I really like how they demonstrate that, where this piece right here is 1/2, and these two are more than 1/2, and then the next four were more than 1/2, and so we end up adding a whole bunch of 1/2s, and that diverges. In general, we're going to say that if they say, what's the sum, okay, like right through here, on this one, find the value if it exists. Yes, we can do that because it's geometric. So when we see these problems, we want to ask, okay, is it geometric? And then is the absolute value of r less than 1? If we can say yes and yes, then we can get an answer. If we cannot say yes to either one of those, for this course, now when you get into BC calculus, then the C topics, there are situations, other things that converge. But for our class, both in PreCal and in IB, what we're looking for, the only infinite series that converge for us are an infinite geometric series where r is less than 1. Okay, so on this next one, so find the value. I'll let you do that later. Go check my answer key. On this one, does the r value is 3. It's geometric, which, okay, so we answered yes to the first question, but our r value is 3, and so we could say it does not exist. I don't want you to tell me that the sum equals infinity, because the sum of something, whatever this is, should equal a number. Okay, if you can't give me a number, don't tell me it equals infinity. Then you would tell me that the sum, that was a little cloud there pretending that this is just what, I don't really care what that is. Don't tell me that it equals infinity. Tell me that it diverges, or tell me that the sum does not exist. This one does not exist because that's not geometric. It's arithmetic, and infinite arithmetic sequences. Let me say that again. Infinite arithmetic series do not converge. The next one, yes, we can. That's geometric, and its r value is less than 1. Be aware that they're starting you here at 2. This one you think, oh look, r is equal to 3. Actually, that is not true. Pause the video, see if you can tell me why. Figure it out. Okay, now that you're back, on this one, it's because of the negative right here. So what we would need to do is we would need to rewrite this as n goes from 1 to infinity of 90 times, well, this is 3 to the negative 1 to the n. Well, what is 3 to the negative 1? 3 to the negative 1, n goes from 1 to infinity of 90 times, this is 1/3 to the n. And so our r value is equal to 1/3, which does meet that requirement right there. This one is neither arithmetic nor geometric, and so it does, the sum does not exist. Okay, I'm going to let you go to find the answer key for the rest of these, but I just wanted to talk through a few things. Hopefully you watched that video. I'm going to give you plenty to practice so that you can figure out what's going on. Let me pick one of these to talk through. If they tell you something like, find the first term if the common ratio is this and the infinite sum is that, well, we know the formula is this. So the first term, the common ratio is 1/4, the infinite sum, so we have this. That's a 3, is equal to a sub 1 over 1 minus 1/4. Okay, so I have this 1024 over 3 is equal to a sub 1 divided by 3/4. Well, so I can multiply both sides by 3/4. If I multiply that side by 3/4, those are going to cancel, but if I do it to one, I have to do it to the other. The 3's cancel. 4 goes in there 256 times. I'm not just that brilliant. I just in my head said, well, half of 1024 is 512, half of that is 256. Those are powers of 2, so that was easy to do. So the very first term in that one is 256. And there you go. Go practice. Good luck. Let me know if you have questions.